Let's take a look at another example of a two-sample t-test, but this time how to do this when we have actual data values rather than just the summary statistics. So in this case, we'll look back at our COVID-19 case per million count for Europe versus North America that we started off with at the start of this lesson. And what we see, just visually, is that it looks like Europe tends to have higher COVID-19 cases per million compared to countries in North America. And we can see that as well when we look at the descriptive statistics. It definitely seems like the mean is higher than North America, as well as the median. So is this a significant difference? Are these definitely discernible? Visually and just with the numbers themselves, it definitely seems like it. But let's actually perform the test to verify. So as we see, we're comparing means, so we want to use the symbol mu to represent these. And I'm going to use this notation mu NA to represent those for North American countries versus EU to represent the mean for European countries. So what would our hypotheses look like? So in this case, again, we are assuming that there is no difference between these two countries, right? If they are exactly the same, we would assume that their difference would be 0. So we can say mu NA minus mu EU has a difference of 0. They're the same. For our alternative, we can assume that their differences is not 0, right? We're trying to show that there is a difference. We don't care specifically right now which one is higher than the other. And so now, what is the method that we can use to compare two means? Again, is a two-sample t-test. So let's look at the process on how to complete this using a calculator. So for Art of Stat, what we can do is look for the option to compare two different means since we have quantitative variables here. So let's look at Art of Stat. You'll find the option here, compare two means, that we will select. And we see that it pops up where we can now select for the enter data. We're going to provide our own data. We don't have necessarily, well, we do have the summary statistics, but we have the actual data. So we will choose this one. As always, we'll define some appropriate names for our variable and labels. So what is it that we're actually measuring here are the number of COVID-19 cases per million. And the two labels that we'll use here is, since we're separating them into North America versus Europe, we'll put those in. Then what we'll see is we can actually put the individual observations within these two boxes, group 1 versus group 2. So group 1 is North America. I can just go to the North American list, copy those, and paste it in. Same thing, we can do the same thing for Europe. Select all those values, copy it, and paste it in. And then finally, what is the type of inference that we're performing here is a test for significance. So we're going to choose this one. And our alternative is already matching our alternative since we're looking at a not equal to. This is two-sided versus a less than or greater than. And so all the information that we need is provided here. It again gives us another box plot or any other type that we want to use to be able to visually compare these results. And it does, again, still look like it's clearly higher for Europe compared to the North American countries. But what is it that we're going to look at is the results right here in the table. Because there's two pieces of information that we need. That test statistic, how far our observations were from what we expected. And then looking at our probability, what we find is we're just looking at what is the chances of seeing this data if they were in fact equal. And so what we find is a p-value of 0.043 and a test statistic of negative 2.938 standard errors below what we expected. So let's record those pieces of information. I'm just going to copy and paste it in. And there is our step 3. Finally, step 4, we want to make the conclusion based off what we see here. And since we are making this at a 0.01 level of significance, we need to compare our p-value to that. And we notice 0.0043 is definitely less than 0.01, so we'll make note of that. Since the p-value is less than 0.01, that tells us that this data is unlikely under the null hypothesis. So we're going to reject that null hypothesis. So what does this mean we have evidence of? We have evidence that the alternative is true, that the two means are not equal. Specifically, that they are significantly different from each other.